In this video, I'll introduce you to VMware's Virtual SAN or vSAN product and how you can use it to create a shared data store using local storage. Virtual SAN allows you to use local storage inside your ESXi hosts and to use that local storage to provide many of the features that typically require shared storage, such as high availability, vMotion, and DRS. Virtual SAN is going to be configured on a cluster of ESXi hosts, and what we'll do is we will install local storage on our hosts and combine it in the form of disk groups, and those disk groups will combine to form a large shared data store that is going to be accessible to all of the hosts in the cluster. We'll even have high-speed solid-state drives that will act as a write buffer and a read cache to improve the performance of Virtual SAN. So let's take a look at how Virtual SAN works. In this scenario, we have a cluster of 3 ESXi hosts, and on each ESXi host, we've got some local hard disk drives, and we've got a couple of solid-state drives installed on each of these hosts. In this case, this is what we refer to as a hybrid configuration in Virtual SAN. And with a hybrid configuration, here's how it works. The hard disk drives provide capacity. This is where our data is persistently stored, is on these hard disk drives. And that's their purpose, is to provide that kind of persistent storage of our data. Whereas the SSD devices, solid state drives, are going to act as a read cache and a write buffer. And the goal is to have most of the read and write operations performed on SSD so that the entire cluster gets SSD type performance. So in this scenario, we actually have 4 disk groups, right? Each disk group is going to be made up of one SSD and then a group of capacity devices behind that SSD. So essentially what we're doing is we're taking the storage hardware that we've installed locally on these ESXi hosts, and we're grouping these ESXi hosts together in a cluster, and then we're combining all of that local storage to create this one big shared data store called our Virtual SAN data store. And what we're doing is we're creating a shared data store that is accessible to all of these ESXi hosts. So for example, let's say that you have a virtual machine that happens to be running on host ESXi03. So here's my VM, right? I got a VM that's running on host ESXi03, and I want to vMotion it to host ESXi02. Well, because this data store is shared by all 3 of these hosts and is accessible to all 3 of these hosts, let's say that this virtual machine's VMDK just happens to be located here on host 1. I can now vMotion that virtual machine. It doesn't matter which host the virtual machine's files are actually located on, because all of the storage is accessible to all of the hosts in that cluster. So now we've got many of the advantages of a traditional storage array when it comes to shared storage and feature availability, but we didn't actually have to invest in a hardware storage array to make it happen. And really the fundamental element that makes all of this work is a high-speed network running between these hosts. So what we'll do is we'll define a VM kernel port on each host that is going to pass storage traffic around, right? So for example, if I've got a virtual machine here on ESXi01, when it puts out those storage commands, they're going to hit a VM kernel port, and they will be directed over my Virtual SAN network to whichever host that VMDK happens to reside on. So now my VM can move all over the place within this cluster. I can vMotion it wherever I want. I can turn on DRS and have that VM move around. And this high-speed Virtual SAN network that I've created will be used to carry all of that storage traffic. And the other critical component of virtual SAN, and the piece that really makes it work fast, is this read cache and write buffer that we are going to establish using SSD. Right, so if I have a host with a disk group on it, part of that disk group will be a flash device, SSD. And when data is read, hopefully it will be read from that SSD layer. So 70% of this SSD on each host is going to be allocated as a read cache. And the read cache contains all of my most frequently read data. And when the data is read from my read cache, the latency is very low because it's SSD. It's much faster than a traditional hard disk drive. So let's say that virtual machine 1 on our far left here in the purple block needs to read some data from disk. And the read request flows out of the virtual machine. And in this case, it just so happens to be some frequently utilized data that was contained in the read cache. So we can see here the result is very fast, right? The read operation happens very quickly. The SSD provides the data really quickly, and the read operation is very, very fast. Right? Let's say now that the virtual machine needs to read some data that is much less frequently accessed, right? Some data that it doesn't usually need. Well, that data is going to need to be retrieved from the hard disk drive, right? Because it's not some of that high value data that's stored in cache. And so those read operations are going to be much slower. So by putting the most valuable data and the most frequently accessed data on SSD, right, by maintaining a copy of that data there, most of our read requests should hit SSD, and it should give us SSD quality read performance. Right? Same thing with writes. 30% of the SSD is going to be allocated as a write buffer. So when my virtual machine needs to write some sort of data, it's going to be written to SSD. So here my virtual machine has some write that it needs to perform. That write is going to be performed on SSD, and then after the fact, the SSD will actually write that data to the long-term persistent storage of my hard disk drives. So as far as my VM is concerned, every write is happening at SSD speed. And then after the fact, this process is transparent to the VM. Those writes are actually pushed to that persistent storage. So that's just a brief introduction to the virtual SAN product. And again, as a quick review, virtual SAN is configured on a cluster of ESXi hosts and can leverage local storage to provide shared storage. The local storage is in the form of disk groups, which have SSD devices as read and write buffers. And then we have disk groups that include, of course, SSD as a read cache and a write buffer, and also some sort of persistent storage behind them. And we have to have that fast, high-speed network as well to interconnect those ESXi hosts so that our storage commands complete